Record. All right. So today we are going to talk a little bit more about for loops and really more just how to use them and what they might be used for rather than how to build them. Because I think last class we pretty much established how to build a for loop. So today we're all talking about applications of for loops. And before we talk about for loops, real quick, we're going to take a brief detour and discuss a topic called compound assignment operators. So when I want to update the value of a variable using its own current value, you can totally do that. So if I have a variable called mynum equaling 5, I can print it. I'll see 5. If I say mynum equals mynum plus 5, I'm going to use the current value of mynum, 5. 5 plus 5 is 10. Then we're going to use that value and assign it to our variable. So when we do an assignment, we're always going to fully evaluate the right side of our variable, or the right side of the assignment, and then we will assign the value that results. So 5 plus 5 is 10, so now mynum equals 10. There is an easier way to do this, though. If I want to avoid retyping my variable's name, I can use a compound assignment operator, which looks like this. It's going to have the operator I want to do right in front of the equal sign. And this is shorthand for saying mynum equals mynum plus 5. I'm using the value in mynum, going to add 5, and I'm going to set it equal to what I'm going to assign it to mynum again. So I'm using this to simply update the value in that variable. And this will perform the exact same calculation as the previous slide. So this process, having an operator equals, will work with any of the 7 binary mathematical operators we learned about. So we can update a variable's value in up to those 7 different mathematical ways. We can add, subtract, multiply, divide to get a float. Sorry, divide to get a float, divide to get an int, exponent, or modulus, and update the value of the variable after that calculation. So all of those will work. With this in mind, let's talk about doing a sum with a loop. One of the most common applications of a for loop is finding the sum of a sequence of variables. And we can do this by storing our temporary total in a variable and then updating that variable each time we go through the loop. So if I say my total starts at 0, so I have my total value, it equals 0, then my loop is going to start. What's my first value for I going to be?
What's the question again?
What's the first value for I going to be?
0. Oh, 1.
It's going to be 1. Absolutely correct. So when I is 1, we're going to add the value of I to our total. 1 plus 0 going to give us 1. I is going to go to 2. 2 plus our previous value in total. 2 plus 1 is 3. The next value of I is 3. 3 plus 3 is 6. Is our loop going to continue after this? Or is 3 the last value for I?
Yeah.
3 is the last value because we're going to stop just short of our ending value. So we're never going to include that number. So our final value for total is going to be 6. So we print 6. Does this process for finding the sum generally make sense? Right. Yeah, it's just important that we make a variable to calculate our total, calculate the sum, and we need to declare that variable outside of our loop. Otherwise, we won't be able to access it again after the loop. So we're going to talk a little bit about a specific type of variable, and they're called constants. Constants are variables whose values you're not planning to change throughout a program. And we usually show that a variable is a constant in our programs by putting its name in all caps. So if you write a variable or you see a variable whose name is in all caps, you know that that is meant to be some constant. We use constants when we have a value that we're planning to use throughout our program, and we want to give it a readable name. So if I have a number that I'm going to loop to a bunch of times, I can make some max value, and then instead of just having that one number, I can use that max constant anywhere I would use that number, and it'll operate the exact same, but it reads a little bit more clearly. This also lets me localize where that value is going to be changed. So if I make my min and max values for a for loop, I can use those min and max values throughout my program. And if somewhere down the road, I want to change what those values are, I don't have to find every single place in my program where they exist. I can just find the one place they are at the top and say min is now a different number, max is now a different number, and that affects my whole program. So constants are sometimes useful in our programs. So if I add a couple of constants to my summing with a loop example, I can make my min equal 1, my max equal 4. Then I'm going to use that min and max variable in my range. And this is going to do the exact same thing as it did before. And later down the line, I could even change that 4 to be a 7, and then I could find the total from 1 through 7 instead if I wanted to. And then I don't have to hunt down everywhere I used a 4 to loop until 4 and change it to 7. Does that idea of using constants make sense? Sweet. All right, so what do we think would happen if I put in a for loop inside another for loop? So first thing to point out before we actually talk about this is that I and J, we have two different letters. We have two different variable names for the iterator in each of our loops. So this is because if I use the same name in both those spots, if I try to use the name inside of the second for loop, Python is not going to know which one I want to use. It's going to default to using the most recent one. So if we have two loops, one inside the other, we want to make sure that we have two different iterator names. Otherwise, we might run into some issues. Notice all of this, also the structure. So we have our first for loop, which everything inside that for loop is indented to this level. And then our second for loop has a second level of indentation for the stuff inside of it. So this line of code is inside of both of those for loops, but this is the one that it's tied to because it's got that indentation there. All right, so with all that in mind, what do we think this is going to print? Let's just go let's go through our for loops. What is our first value for I going to be?
0.
I is going to start at 0. What's our first value for j going to be?
0.
J is also going to start at 0. Now, which one of these is going to update first?
J.
J is going to update first because it is the inside loop. So when we have a loop inside of another loop, that second loop is always going to finish its looping before this one even starts its next loop. So J is going to increase to 1. I is still going to be 0. J is going to increase to 2. I is still going to be 0. Is that all the values that J is going to hold?
Yes.
Sure is. So now that the J for loop has finished, we're going to go back up and we're going to have I go to the next value. I is now going to go to 1. And then we're going to essentially restart our J for loop. J is going to go back down to 0. We're going to start it over. J is going to go 0, 1, 2, while I is still 1. That's a terrible 1. J has now held all of its values again. We're going to jump up and increase I again. I is now 2. J is going to be 0, 1, 2, while I is 2. And then both of our loops have now finished. So this is all of the values that we will see on our output. Does the process for finding out how a double for loop works make sense? Does that track? I've got a little table to show what it looks like. Very nice colors. So just remember, when you have nested for loops, and that is the word for this, when you have a for loop inside of another for loop, those for loops are nested. So when you have nested for loops, the loop on the inside is going to fully complete its looping each time the outside loop does one loop. So we've got our first I loop, our second I loop, and our third I loop. And within each of those I loops, J loops or does its 3 loops. Cool? All right. And we can tell how many times total this is going to run by multiplying our 2 range values together. So we know this is going to happen 9 times total because we have 3 times 3. All right. That is our lesson for today. Stop my share. Stop.